Hi, this is Dr. Taheri. I have another Maple tutorial. Today we would like to talk about matrix operation using Maple. Maple is a very powerful software for various linear algebra operation. So we start with something very basic, and that is how to enter a matrix. So there is an option here, matrix, and we can define the size of the matrix by here. If I want to have, let's say, 4 by 4 matrix, that is these two can be changed. I can simply go and click on choose and hold my left click, and I can drag and I can define the size of the matrix here if I want to have 4 by 4. And of course it could be a custom made, it could be random, it could be an identity matrix. I can have different shapes. It's all defined here. It's going to be diagonal, upper or lower or tri, symmetric, and so on. And also I can actually define the type of the data. So it could be integer 1, 2, it could be float, it could be a complex value. Let's just enter a random 4 by 4 matrix. Now if you want to add this matrix to another matrix, so all you need to do, you go to the operator and here you click plus, and you should know that when you do addition and subtraction in linear algebra with two matrices, they have to be identical shape. So I add another 4 by 4, and if I press enter here, so the answer would be this member 74 negative would be added to minus 9, and that is minus 83. Now if you want to continue that, you can subtract that from another matrix and again add to another matrix, and you can continue this, and of course the answer would be this number plus this number minus this number plus this number, and that's here is the answer. In terms of multiplication of matrices, so you have to be careful that when you define a matrix, and the matrix, imagining it's going to be 5 by 3, so we have 5 rows and 3 columns. The next matrix that you want to multiply, it has to have 3 rows and 5 columns. So the number of the columns in the first matrix would be equal to the number of the rows of the second one. And in Maple, in order to multiply two matrices, you have to use this center dot here. And as I mentioned, that next one, it has to be 3 by 5. Enter. And of course, if you press that, the answer would be a 5 by 5. 5 by 3 multiplied by 3 by 5 is going to be 5 by 5. So now I can actually go here and I can multiply that by a 5 by 5 matrix here. And what Maple does is first multiply these two, and the answer would be 5 by 5, and then multiply by 5 by 5 by this 5 by 5. It could be actually 5 by any dimension. There are several other operations using Maple. For example, if you have a 5 by 5 matrix, you can find the determinant of this matrix. So you go to right click, you go to standard operation determinant. This is the value here. You can simply right click and find the inverse of a matrix, which is a very handy feature. This is the value here. Inverse of a matrix, based on definition, is when you multiply inverse of a matrix by a matrix itself, the answer would be the identity matrix in that dimension. So let's just practice that. So if I have this gigantic matrix, copy, and paste it here, and multiply that by my initial random matrix here, copy. So the answer would be nothing but identity matrix in 5 by 5. Now of course inverse has been defined only for square matrices, 5 by 5, 4 by 4, and any other dimension m by m. But also there is another inverse like operation. It's called pseudo inverse. and that is for other sizes of matrices that are not square. This is really an important operation in signal processing and perhaps doing any kind of signal filtering. Let's just define a 4 by 3 matrix, and then I want to find, let's say, the inverse of this matrix. So you right click, and in this case obviously is no inverse, it's called the pseudo inverse, and this is the answer. And in order to actually let's just think about this, is 4 by 3 multiplied by 3 by 4. The answer should be equal to 3 by 3. Let's just practice that. I have this matrix, copy, add it here, paste, multiply by this pseudo inverse matrix. Just be careful, just select the matrix, copy here, paste, and I made a mistake here. This has to be actually the other side. So let me just it has to be the pseudo inverse of the matrix multiply by the matrix, which is it's not work the way I want. So just find this, copy here. Let's just delete this. Want to cooperate? No. Let's see what I'm going to get here. So paste. So this is not going to work. Let's just go here. Okay, there we go. And paste here, and the answer, of course, would be what we have here as a 3 by 3 identity matrix. So the inverse of a matrix in this case is pseudo inverse of a matrix multiplied by the actual matrix, and the answer is an identity matrix. One of the applications of linear algebra is solving equations and variables, and we learned before that we can do that using Maple. So let's just write the simple equation here. 3 equations, 3 variables. I have x plus y plus z is equal to 12, comma 2 multiplied by x, 2x minus 3y minus 4z is equal to 0, and then I have x plus z is equal to minus 1. I have 3 equations here. I can just right click, go to solve, and go to solve it. So I get 3 values for x, y, z. X here, y here, and z is the other value. And now, of course, there is another method, which is simply a linear algebra method for solving this equation. For that, I have to define first a matrix that is 3 by 3, and this 3 by 3 matrix is the values that are associated in each equation to x, y, z, the constraint matrix. So I have a 3 by 3 matrix here, and in that case I don't want to do random. I go to custom values, I press it here, and in this particular case, as you see, I go here, the first is 1, 1, 1. The next one is second equation is 2 minus 3 minus 4, and the next one is 1. So for the y is 0, and for the z is equal to 1. So you can see that these values represent the values of x, y, z constraint in each equation. So this is my first, and then of course I define constant values, which is in this particular case is 3 by 1 vertical matrix. So the values are, so let me just go here, 3 by 1, so values are 12, 0, and minus 1. And now if I want to find the value of x, y, z, the variables, all I do, I find the inverse of this matrix. I write here a to the power -1 and multiply that by b. So here, multiply by b, and the answer is the values that I already calculated before. So x is 35 divided by 6, and y is 13, and z is equal to -41 divided by 6. There is another method that you can use, and that's kind of interesting if you do Gaussian elimination. So this is a very interesting method that they use in various engineering application, including in electrical engineering. So Gaussian elimination is when you try to convert a matrix into lower diagonal, all the members below the diagonal equal to 0. Let's just see how we can use this. So let's go here. You go to tutors and you go to linear algebra, and then you go here to Gaussian elimination. There's another method called Gaussian Jordan elimination. But now what I'm trying to do is that I would like to put these two matrices here. So, and if you go here, this is exactly, if I just go to edit the matrix. So what I have here is a 3 equation, 3 variables. So I would put these values here, 1, 1, and 1, and the value here is 12. The next one is 2, -3, and -4. Value is equal to 0, the constant value, and then we have 1, 0, 1, 1, 0, and here is 1, and the value is -1. So let's just display that, and you can see what I generated is exactly the same as these 3 equations here. I have x, 1x plus 1y plus 1z. Here is x1, x2 equal x3 equal to 12. This is the second equation, and this is the last equation. And now what I do here, I can go to step by step. You press here, next step, and then again next step, and again next step, and eventually what you do that you turn this one to a matrix that it has these 3 values here, because the 3 by 3 is equal to 0. Therefore the final equation here is x3 is equal to the value that we have here. So x3 is equal to this value, 41 -41 divided by 5 divided by 6 divided by 5, which is the answer is equal to -41 divided by 6. So this is one of the other methods that you can use in order to solve. Of course, there's much more than that involved. Now also you can find eigenvalue, eigenvector using Maple. So if I have a 3 by 3 matrix, I use or maybe use the same matrix here. Just click here, copy, and of course not every 3 by 3 or any matrix has an eigenvalue which is a real number, so you could have complex numbers. So let's just exercise that. We have this matrix here, so I can simply click here. Let's go here, go to tutor, and then what you have here, go to again linear algebra, and now you want to have eigenvalue, eigenvector. So if you want to find the values here, let's just go back here. So this is the definition of eigen value. So if you have a matrix here, so it's M and this is minus T, identity matrix, the answer will be A. So you want to find the value of T, and of course in that case you end up solving this equation here, and this would be the answer in this particular case. So you have 3 by 3, you have 3 answers here. As you can see that these is simply what we calculated here. So these are the eigen values. So we can also calculate the eigenvector. Here you can even right click and you can go to calculate here eigenvectors here. So the eigenvectors are these. This is what we have here. This is the eigenvector here, and we have two eigenvectors in this particular case. And this concludes our presentation today.